What's up, guys? So we are solving the GRE Math A768 form. So 58. If fz is an analytic that maps the entire finite complex plane into a real axis, then the imaginary axis must be mapped onto. Okay, so we have a function from Z for complex to a complex, and there's some finite region mapped onto the map into a real axis. And ask about the what is the map for this imaginary axis. So key is that guess the answer, since we only have 3 minutes for each question. So you cannot do the entire proof just when you do it. It's like your midterms and you don't have this time. So you don't have so much time. So you need to guess the answer. So if I solve this question, I would say, okay, suppose I let function of z to be 1. Then this function is okay because it maps all complex plane into a real axis. Actually, it maps all the point to 1 point. All the point on complex plane to a 1.1. So what's the image of this imaginary point? The answer is 1. So the answer is B, a point. B. Yeah, it's very easy that we guess the answer and then we solve it. Okay, but since this is YouTube tutorial, so I cannot give you this type of answer. Okay, but why? Okay, can we prove it? Okay, so actually we can prove it since we know that the function is entire. So we have the Cauchy Riemann. But we know what? We know that the analytic function maps the entire finite complex plane into entire finite complex plane to real axis, right? So that means for analytically, this v is 0 in the complex plane in that region A. So we have f is u. But you know that when you only have real parts, then the Cauchy Riemann equation can only hold when u is constant, because now ux is 0 and uy need to be 0. The derivative of ux derivative of uy need to be 0. So this tells you that f is constant. So you have some constant region which is entire, and this region can be analytically extended. So the answer must be a constant. Okay, so the answer is C. The answer is B, is a point. Okay.